Garments Department in Damiata University, Egypt. He is going to present today mathematical simulation of heat and mass transfer in primary school uniform using cotton and blended cotton polyester 50-50 fabrics. The floor is yours, Doctor.
Good morning. In fact, I would like to welcome our guests from abroad in Egypt. So we hope to see them again in Egypt. For the moment, I'm representing the Higher Institute of Engineering and Textile Technology because I'm the dean of this institute. We'll start then. First of all, I would like to thank Dr. Said Nashar to invite me here for the 5th SmartX 2015 Egypt. Also, I would like to represent my gratitude to Professor Dr. Said Higazi and Dr. Said Nashar Qaim. Sorry for that. The cooling effect of respirations, evaporations, and microclimate system on a human continuous comfort. Would like really to discuss this event because we are really dealing with very interested or very serious part of our body, which is the next to skin garment. Human existence depends on the relationship balance between energy from body heat and the ambient transferred energy. Microclimate and the skin clothing systems, and especially the skin responses, relates to the moisture and heat transfer within this system plays a critical role in skin comfort by textiles. The cooling effect of respirations, evaporation, make use of the very large heat of vaporization of sweat. However, the skin is a large barrier organ that protects the human body from environmental hazard. The clothing system provides an extra layers of barrier to enhance thermophysiological and sensorial comfort of the wearer. Waste heat from body, skin must be dissipated all the time and whenever necessary, aided by evaporation of sweat from the skin. Clothing has as one of its main functions the control of heat and moisture transfer from the body to the environment. The physical properties of the fabrics, material, and construction means structure and design, as well as the physical activities, the metabolic of the body, have been considered in this research by which affecting the fabric thermal properties. Skin, microclimate, and inner layers of clothing. First, the basic system is such a heat flow from the central up to the skin surface by conduction and vascular mechanism, with the skin layers preferably, which transport heat from the producing heat areas within the body to the skin surface. The heat is transferred by skin surface to the microclimate. Microclimate means the distance between the garment and the body, next to skin, what the garment is next to skin. And the garment layers associated with the exchange of heat by process of conduction, radiation, convection, and evaporation. Evaporation is very really interested part of this heat transfer from the body to the ambient condition. Secondly, the natural control systems which control the skin blood flow, sweating and shivering necessary heat to maintain normal body temperature for cooling. The maximum value occurs when the entire skin surface is 100% wet from regularity sweating. Both depend on the evaporative potential of the environment as a function of air movement, vapor pressure gradient from the skin surface through clothing to ambient air, and resistance of the clothing against the sweat transfer of water vapor. Let us make a comparison between human and alligator, say. Human body as a male can dissipate 1,600 to 1,800 kilocalories per day. Female is less, little bit, 1,300 up to 1,500 kilocalories. But alligator, 6 kilocalories per day only. Let us make a schematic diagram, the relationship between the fabric or the underwear and the skin. Suppose this is the garment, the fabric, this is the skin. The skin is sweating water. I mean, just water, not evaporated. Moisture, and then these fabrics absorb this moisture, evaporated to the ambient condition, and then exchange with a fresh air, so the skin will be cool. In order to be comfortable thermophysiologically, the clothing microclimate should lie in the range of 35 plus minus 2 centigrade, 50 plus minus 10% relative humidity, 25 plus minus 5 meter per second air velocity. The fabric has its insulative ability as water and air permeability, absorbency, wickability, and other properties related to the thermal comfort. Why is that important that the core temperature remains constant? To keep vital organs warm, the enzyme systems must operate in optimum condition. The periphery of the body can withstand some deviation from the core temperature. Human temperature variation chart. So we have to understand how much our temperature is supposed to. At 30 centigrade normal body temperature, which with all the doctors measuring the temperature of a human body started from 33. Somebody our common knows that our temperature is 37. My temperature is 36.5, different, which vary between 36 up to 37 to 0.5 centigrade. At 35, hypothermia is less than 35 centigrade, intense shivering, numbness, and bluish gray of skin, possibly of the heart irritability. You can see that in the very cold weather that your fingers is going to be bluish. At 33 centigrade, moderate to severe confusion, sleepiness, depressed, reflex, progressive loss of shivering, low heartbeat, shallow breathing, subject may be unresponsive to certain stimuli. So when your temperature coming down up to 28 centigrade in a very, very cold weather, if you're trapped in a very trapped weather, say in Europe, so you will be severe heart rhythm. In this aspect, a mathematical models has been developed to describe the dynamic heat and moisture transport behavior. Textile material fabrics physical properties, as we used, we have measured the weight per unit area, the air permeability, the water permeability, moisture again. Material, we have used two types of yarn were used, pure cotton, 16 by 16, the count of warp and weft, yarn and weft, twist factor 3.8 Z twist, Giza 83 Egyptian cotton. And the other one is blended cotton polyester 50-50. 4 types of fabrics were prepared on Solzer Ruti. A set of fabrics has been made with equivalent yarn and fabric geometric. So we have to make this design to get a very near results. Equivalent yarn and fabric geometric. Full structure of the fabric consists of 16 by 150 over 40 warp 60 weft. 60 by 60, 87 by 30, 16 by 16, and so on. This is for construction we have done. While is the first structure 100% polyester weft, 150 by 2 denier, and 100% cotton with work count of 16s. 4 fabric designs were designed to be a plain 11, 12, 22, 12, 13, satin 4 means fabric geometric is the same. The yarn through the garment swell at high humidity could have a large influence on the measured air permeability for hygroscopic fibers such as cotton, wool, represented the phenomena of TESV, the thermal effective specific volume. The relationship between the air permeability and thickness represented the thermal effective specific volume, but this relation do not show, this phenomena is very common, but for my opinion, that this relationship do not show the resistance of the fabric when the fabric contain a moisture, vapor, or sweat. So, it could be represented therefore by different way, by the air permeability and the weight of the fabric. I called it the thermal effective resistance volume. This relationship means as water accumulates through the void spaces of the yarn to yarn and the fabric by hydrophilic or hydrophilic groups, there is absolutely change in the fabric thermal insulation. We can see here that the relationship between the fabric construction, and the thermal effective resistance volume, that at the very wet fabric give a very low results of the thermal effective resistance, because this is very wet. I mean 100% water inside the fabric. When used the cotton polyester, I mean blended cotton polyester, we can see that the wet is really behave differently. Whenever the fabric at maximum holding water, the thermal effective resistance volume rapidly increase, whereas the model 100% and 100, 50-50, the total sum of them, as I designated it, the behavior is not significant except at the satin design. So satin design really gave me a very, very interesting water absorption and heat transfer. So the maximum holding water at fabric, it depends on three factors. As I designated, if we say S, the maximum holding water, A over B plus C, means A, the fabric construction parameter, B, the fabric specific weight parameter, C, the fabric specific gravity parameters, which all of them depend on the volume fraction, which volume fraction is depending on the porosity of the yarn, on the fabric also. The foregoing discussion has served to show that there are several ways in which heat and moisture can pass through fabrics in clothing environment. For example, absorption, diffusion, evaporation, condensation, and wicking of water through fiber assemblies. All have their own associated heat transport mechanism. On the other hand, the specific fibers arrangement in clothing fabrics govern the liberation of the sweat and the heat transfer from fabric and the presence of actual diffusion and water evaporation. If we can see this diagram really is representing that this is a skin, this is a microclimate, and this is a fabric, the garment, and this is an environmental condition. So the skin is wet through the microclimate region. The fabric absorbed that sweat, so started to evaporate that sweat from the skin to the ambient condition. So the four mechanism is convection, radiation, conduction, evaporation. The clothing comfort can be divided into three groups: physiological comfort, tactile comfort, thermal comfort. Physiological comfort is mainly related to the latest fashion trend and bears the attention to the properties of the fabric. The thermal comfort is the ability of fabrics to maintain the temperature of skin through transfer of heat and perspirations generated by human body. Skin sensation wear comfort, which concern the mechanical concept of the fabric with the skin. Softness, breathability and movement, lack of breaking, irritation, and cleaning when damp. The comfort characteristics of fabrics mainly depend on structure and design. Structure being warp and weft, and design means plain, twill, satin, types of yarn used. Then the transmission of air, heat, and water vapor from the skin through the garment are the most important factors in clothing comfort. So the heat is produced by metabolism, the very, very really interested mechanism. By other way, QM heat dissipated to the ambient due to the metabolic heat. So we are producing temperature by the metabolic heat mechanism inside our body, producing and rate of working. So this for equation to make the temperature transfer to the ambient conditions. Like evaporation, heat transfer, radiation, heat transfer, convection, conduction, etc. Heat transfer by conduction is really depend on the conduction heat transfer coefficient of the used material. So we are going to now to dealing with the fabric. So we have to know, this is really a question of heat transfer of any refrigerators, whatever the equation, but this is normal in refrigerating equations. So I use these equations to be applied on the fabric. So here the factor we have to understand or have to know the conduction heat transfer coefficient of the used material. The other ambient air temperature, Ts. Ts here is the temperature of skin. Ta is temperature of ambient condition. So skin temperature, Ts, surface area of garment, the area. The heat transfer by convection, the rate of transfer by convection determined from Newton's law of cooling, which is depend on psi, the convection heat transfer coefficient of the fabric also. Actually, its value depends on garment fitting, fabric design, nature of sweat motion through the fabric structure. The heat transfer by radiation depends on the emissivity of the skin, because this is the organ which we have to deal with fabric. And so two things deal with each other, the garment next to skin and the skin. Delta is a Stevens-Boltzmann constant equal 5.7 multiplying by 8 to the power minus 8. So air does not interfere with the radiation heat transfer from the person to the ambient. Heat transfer by evaporation is the very most interesting one, because this is the one making cooling to our body. It depends on the vapor pressure between the skin surface and the microclimate. So we have to find how much the pressure difference between the microclimate of our body and the ambient condition with the garment and surrounding air. So the evaporation equation is depend on the air evaporation sweat concentration, the sweat transfer coefficient, and the air specific heat transfer that have got value, and the pressure of the skin and the pressure of the ambient condition. So the different pressures give the mechanism to work to cool down the body. Also the Ta ambient temperature and the gas constant and epsilon latent heat of the water equal 2430 kilojoule per kilogram. So we have to use this chart really to measure or to work out how much difference pressure difference between the ambient condition and the skin. Metabolic rates increase up to 4 or 5 times sitting resting. So, the metabolism when you're doing some activities, so it will increase. So we have to know how much the skin temperature, we can measure it, but it really is not accurate enough. So we have good formula for that. So the T, the temperature of the skin is equal to this equation. You can find it in actually book. So skin temperature, say we have ambient temperature is 20, so the skin temperature will be 31.5. If we have got ambient temperature 31, the skin temperature will be 34.1. So you can see the change from 20 centigrade ambient to 31 ambient, well, 31.1 to 34.1 means 3 degrees centigrade difference. Even the temperature is very high. The metabolic of 4 guys who have used is 3 children, 3 ages of children, 6 years old, 9, 12, and the metabolic of them is 8 watt per meter square centigrade, and 10 and 14 for the 12 years old. So the equation here, we have done it to represent the heat transfer of the whole things, started from the garment, skin temperature, the skin pressure and microclimate, and the garment itself, its properties, and the conduction heat transfer, the radiation heat transfer, and convection heat transfer. What we have found here, heat transfer at the fabric structure, we can find really interesting things. At wet, very wet, I mean the fabric is completely wet, at relative humidity 80%, we can find the heat transfer is very high, this one. The lowest one, the first one, the lowest, is at dry fabric at relative humidity 20. This is mathematically integrated. Effect of the fabric structure at different condition versus heat transfer cotton polyester 6 years old. We can find the same things, you know. The most interesting thing is at the fabric is very wet, I mean completely wet. At relative humidity 80% give the higher heat transfer. The lower one is dry at relative humidity 20. The contribution of blended cotton is higher than the pure cotton. In fact, this is very interesting because we know that polyester, it doesn't absorb water, but the things that the porosity here is very high. The combination between the polyesters and the cotton, the porosity, which really depend on how much the absorption of water through this fabric, giving a very high interesting. The high humidity prevent rapid evaporation of liquid water on the skin, give the body the sensation of heat, and eventually trigger the sweating in the first place, also causing uncomfortable feeling for the wearer. So suppose now we are, sometimes in tropical conditions, the people take off their clothes. That give them the feeling that they will be cooled down, but it's not really good. Because, now if you are setting without fabrics or garment next to skin, there will be only radiation and the convection mechanism will work. So the other 2 mechanisms never work. The equation of heat transfer will be only this one. Means that radiation and convection. Radiation from the body to outside. Convection from the body also to ambient condition, but no conduction, no evaporation. So the very interesting really thing, if you would like to sit down or sitting without clothes, will be this diagram or this graph. Here, from 20 up to 30, the temperature is coming of the skin is coming down. So after 36 degree, the ambient condition will inject the heating of the ambient to your body. So you'll feel very warm. Effect of the structure heat versus the heating transfer, cotton fabric 6 years. You can find at wet condition the very high heat transfer. Dry one is